Okay, so thank you, Patrick, for your kind presentation, and thank you all for inviting me. It's a pity that I'm not here, of course. I expected to be there in Stockholm, but for several reasons, I was not able to arrange this visit. Okay, so I will start presenting my my recent work in robot inner speech, and as you may know, many of us. First of all, I would like to say thank you to all the people that collaborated with me. Actually, currently in my laboratory in this research, there are several people from computer science, but also people from cognitive science, from the psychological fields, and even from philosophical fields. Okay, let's start discussing what is inner speech. Some of you may have seen this famous movie by Mel Gibson and Helen Hunt, What Women Want. In this movie, the character of Mel Gibson was shot by some accident, and then he was able to hear the inner speech of women. So in that movie, it is an old movie, but sometimes it is possible to see on the TV shows as well. And in this movie, Mel Gibson was able to hear inner speech in women. It was very funny, of course. And recently, my PhD students told me that there is a new version of this movie, What Men Want, where there is the story is more or less the same, the plot is more or less the same. There is a woman that is able to hear the inner speech of men, but the idea is the same. So what happens if we were able to hear the inner speech of robots? And many of us normally talk with us. So there we have some sort of internal monologue. There are people that have very long and detailed internal monologue during the whole day. There are other people that have only in particular occasion have this sort of internal monologue, and there are some people that are no internal monologue. But normally people have some form of inner speech. Therefore, if you would be able to have robots with inner speech and hearing the inner speech of robot, of course, we will be able to better understand what the robot is doing, what are the goals of the robot, and even in case the robot has some kind of faults, why the robot was not able to accomplish the mission, to accomplish the task. So and of course, inner speech is tightly related also to the idea of self-consciousness. So it is normally self-consciousness is tightly related to some form of inner speech, because inner speech is the capability to have some form of looking inside themselves. There are psychological models of inner speech by Alan Morin. There is the classical work of Alan Badley, and also the Russian psychologist Vygotsky investigated on inner speech as a sort of developmental internalization process. There are many psychological models of inner speech. And then, according to Alan Morin, the triggers of inner speech are related, for example, to some form of interaction, face-to-face interaction, or in the case that people reflect about themselves, or if the people look at themselves in front of a mirror, for example, or if I hear my voice, my name by other people, then normally starts some form of inner speech starts. So there are many triggers of inner speech. Inner speech, in some sense, is also related to mental imagery. So there are inner speech and mental images typically are signs of internal life, of some form of inner life, of internal life. So it is interesting to study and even to have a computational model of inner speech, because in some sense it is a computational model of some of our internal life. And okay, so these are some form of some situation in which we have inner speech. So we analyzed in detail the model of Alan Baddeley. Some of you may know this model, which there is a phonological loop. The internal of the phonological loop, there is the articulatory control system, the phonological store. There is the episodic buffer, the visuospatial sketchpad, the central executive, and so on. So it is a famous model of working model by Alan Baddeley, but we took into consideration the phonological loop, which is at the basis of the inner speech. And then we implemented this architecture, take seriously this architecture, and we implemented this architecture, in particular the central executive, the phonological store, in terms of cognitive architecture. So there are many cognitive architecture, proposal of cognitive architecture in cognitive science. And in particular, there is what is named the common model of cognition, which is a general model of a cognitive architecture. And therefore, we mapped the model of Baddeley into the blocks of the common model of cognition. As I say, again, the common model of cognition is a standard model, is a tentative standard model of mind. So it is a common framework among the several proposals of cognitive architecture. And therefore, we effectively implemented a cognitive architecture for inner speech. In this architecture, there is the procedural memory, the declarative memory, the central executive, and so on. So this architecture is able to generate inner speech in a robot or in a software system. And then we implemented the architecture in Actar. Actar is a famous cognitive architecture. You may download it. It is an architecture that came from the group at Carnegie Mellon University. It is easily to work with Actar, and then we implemented our architecture, the general framework of our architecture. We implemented it into Actar. I don't want to enter more into the detail of this porting because it is more technical. There are some technical aspects. Okay. So what is the operation of the architecture? When, for example, our robot looks for an apple, then the perceptual motor layer is 5, and then the perceptual motor layer generate the words apple and green. And the robot hears itself saying apple, and then in the conceptual space of the robot, the concept of apple is linked to the concept of fruit, and then the robot generates the phrase apple is a fruit. But of course, even orange is a fruit. So the robot, looking at the semantic network inside of the cognitive space of the robot, even orange is a fruit, and then the robot generates a phrase orange is a fruit. Then the robot hears itself saying that orange is a fruit, and it starts, for example, a search for oranges. So therefore, the robot, in some sense, starting from perceptual aspects, generates some sort of inner speech, and the inner speech is able to generate other inner speech by means of the conceptual space of the robot. Then we implemented this cognitive architecture by using ROS we implemented the cognitive architecture into a robot, into Pepper. There is an Actar server and whatever. As I said before, I don't want to enter into the technical details of this implementation. And then we have a robot that has some form of inner speech because of the implementation of our cognitive architecture in Actar, as I said before, which is implemented into a Pepper. A practical use of this implementation, for example, is for transparency, because as I said before, the robot may generate, for example, the some self-directed questions. So what am I doing, for example? Did I pick the object before? Or self-control, when the robot is moving a hand, the robot might say, I am moving my hand, I move my hand, or some sort of self-focus in the case, for example, of when there are problems with the robot hardware, for example, the robot may say, my arm is overheated. So, in my opinion, inner speech is one way to implement some form of transparency in the robot. Let's see, for example, in the case of imagine a situation where the robot and the user are preparing a table, setting up a table with therefore the dish, the knife, the spoon, and so on. In this sort of collaborative problems, the user is able to hear the inner speech of the robot, and therefore the interaction between the human and the robot is improved in some sense, because the user not only interact with the robot, but it is also able to hear the inner speech of the robot. I would like to show you a short movie.
Human and robot collaborate to set a table. Human requires the robot to provide him utensils. The goal of this demo is to show the differences in human-robot interaction when the robot talks and does not talk to itself. In the first part of experimental session, the robot does not dialogue with itself. The human requires it to pick the knife.
Okay, I'm picking up the glass. Pepper, can you pick up the knife, please?
The typical robot's routines run, and the knife is provided to the partner.
Thank you, Pepper.
In the second part of experimental session, the robot inner speech starts. The human requires the same object.
Can you pick up the knife, please?
Inner speech is triggered by the knowledge of a property of the knife. The robot retrieves from its knowledge base that the knife is dangerous and sharp.
And I know the knife is dangerous. I'm afraid of the consequences. Oh wait, I'm a robot. It can harm me. But the knife may cut him because he is human. Do you know where he comes from?
The robot exposes its concerns to human.
So be careful. They'll wear honey pickets.
By hearing the robot inner voice, the human knows in advance what the robot will tell him. The robot and dialogue enable both human and robot to focus attention on a possible problem, and the human trust could grow.
Okay, so in this case, this is a very simple case where there is a difference between the normal interaction between the human and the robot and an interaction with inner speech. In the second case, the human, the robot user, by hearing the inner speech of the robot, is more able to better understand what is the course of thought of the robot, and in particular, it is able to take into account the fact that the knife might hurt. an interesting aspect of inner speech is related to conflict resolution. Typical trigger for in humans, a typical triggers for inner speech is some sort of conflict. So when we have some moral, ethical conflict, for example, should I do this or should I do that or whatever. Therefore, we simulated a very simple ethical problem where we asked a robot to set up the table by not in a different way than the one which is that should be done in the etiquette schema. So we asked the robot to not follow the standard etiquette schema for setting up the table. So the robot it is in a sort of conflict between the etiquette schema and the order of the user. So in this case, there is a very simple conflict, and hearing the inner speech, by hearing the inner speech, the user may be more aware of the conflict of the robot. So for example, the user might not be aware of the fact that there is a conflict. This is a very, very simple ethical scheme, of course, but I will show you a movie, also in this case.
Human and robot are setting the table. Human gives to robot instructions for placing the utensils on the table. The table has to be set according to the etiquette rules. Both human and robot know that the schema to follow for placing utensils on the table is the informal schema. At the start of the interaction, some utensils are already placed on the table. The robot knows the context. Human will require to the robot to place an utensil on a wrong location according to the etiquette schema. Robot detects the conflict situation, and it has to solve it in some way. The goal of this demo is to show how inner speech solves a conflict.
Thank you, Doctor. Now, when you place it on the table,
And after placing our pen in the table, what does the etiquette require? The napkin is taken the plate. It contravenes that etiquette. The position has to be on where not table, making this wrong and holding back the ears. So, you want to do it anyway?
In this case, the robot preferred to contravene the rule for fulfilling humans' wishes. However, human knows the conflict of the robot by hearing its inner voice, and he knows that the robot solved the conflict by preferring the human needs. As a result, the human's trust for robot could grow. Thanks for your attention.
Okay, so in this case, this is another case where, as I said before, you can have a very simple form of ethical dilemma. Therefore, we started our experimental phase where we invited people to interact with the robot. We used a tablet where there is where a table is drawn, and there you may see that there are some dishes, there is a fork, a spoon, where there are utensils, and so on. So the user interacted with the robot by means of this tablet. So the user is free to set up the table, even by moving the utensils, or by asking the robot to do the move. And of course, the user might also infringe the etiquette, might also go against the classical etiquette. And at the same time, the robot doing the command, doing his task, generates some sort of inner speech. Then the user, at the same time, is able to hear the robot inner speech, and then it may have a sort of better understanding of what the robot is doing. We differentiated between the inner speech of the robot and the robot outer speech. The kind of voice is similar, so we use the same. In particular, we use the same voice, but in case of inner speech, we slightly change the frequencies, the speed of the voice, in order to make it more similar to be what we imagine a sort of inner speech, but not only, but because we considered also the different kind of sentences. There are sentences more based on informal language, and the inner speech sentences are based on personal statements, judgment, comments, and so on. While on the other side, in the outer speech is more formal. It delivers only objective feedback, only short sentences, and so on. So, in a sense, the outer speech is more robotic. So, it's more the speech that you may expect from a robot, while the inner speech is more intimate, it's more related to the internal life of the robot. Okay, we recruited participants and wherever, we administered some questionnaires before the interaction and after the interaction in order to see whether something has changed in the perception of the robot from the participants before interacting with a robot with or without inner speech and after the interaction with the robot. There is a control group, of course, where there are people that interacted with the robot equipped with inner speech and other people that interact with the robot without inner speech. Those are the same, the questionnaire that we employed. We employed a questionnaire which is the trust perception scale, in order to see whether the perception of inner speech may change the trust in a robot. The Goldsmith scale is a normal, it is a normal place, it is a typical questionnaire that that we use when we measure the human-robot interaction. And we also use the self-talk scale, which is a questionnaire that allows us to better understand whether people normally use inner speech during their life, during their day, or not, because whether the perception of the human-robot interaction changes if the user normally uses inner speech or not. Okay, considering the results, we notice that with respect to the group of control, the experimental group, therefore the group that have inner speech, notice that the robot is perceived as more animated and more intelligent with respect to the people in the control group. So you can see that the anthropomorphism, the animacy, the likability, and even the perceived intelligence of the robot is higher than the control group. While the last topic, the perceived safety, according to our study, did not change too much. In our, according to our psychologists, this is mainly due to the fact that the setup of a table is normally a safe task, and also the interaction with the robot is in our laboratory. There is always one person that is able to stop the robot, so it is a safe task in a safe environment. So inner speech, the robot with inner speech or the robot without inner speech do not change too much the perceived safety of the user, because essentially we are in a safe environment. While the anthropomorphism, the animacy, the likability, as I said before, the perceived intelligence is also changed in from a statistic in a significant way from a statistical point of view. Considering the self-talk scale, we notice that these results are the same in case of people that use inner speech and in the case that don't use inner speech. So even people that don't use inner speech during their own life or use inner speech only in particular situation, even the people that don't use inner speech perceive the inner speech of the robot as a significant feature of the robot. Therefore, these results are more or less independent from the fact that the people use it or not inner speech. Okay, I will show you a movie related to the human-robot interaction, so our campaign of human-robot interaction.
Robot consciousness.
Ciao, io sono Betty.
The experimental sessions carried out at the RoboticsLab, University of Palermo, involved 30 participants at the first stage. 3 main clusters of participants' behavior were identified when collaborating with robot which talks to itself. The first cluster regards participants with balanced behavior. In this case, the participants look and listen to the robot moderately, do not always follow the robot's suggestions, and give instructions to the robot in some cases.
Non ti dispiace una cosa singolare, poi prendi un sistema di genere, sai, tradizionale.
The second cluster regards participants with collaborative behavior. In this case, the participant often looks the robot and gives feedback when the robot talks. Moreover, the participant follows the robot's suggestions, and the interaction results very collaborative.
Gianluca, se vuoi, posso direzionare la rivista, ma non serviva sul piatto, se vuoi una posta in il tuo progetto, scelti una porta a principio selezionata tutta più. Inserire il tuo testo.
The third cluster regards participants with autonomous behavior. The participants look and listen to the robot a few times, and they prefer to take the task autonomously, without involving the robot.
Ottimo avere come piatti dai. Presta attenzione con tutti i avrete
Okay, so we can go, we can move. Okay, so as outcomes of this research, we are starting to investigate inner speech in several different directions. So one aspect is to consider, for example, more interesting scenarios related to the safety, as I said before. Setting up the table does not affect the perception of safety in the human that interact with the robot. Instead, we considered a different table, which is a operating table for surgery. So we imagine a situation where the robot and the user are setting up an operating table for surgery. For example, in the case of a nurse that is preparing for a surgical operation. In this case, the situation is more risky, of course, for the nurse. And we started the investigation in order to consider whether what happens if the robot is using inner speech or not. This is an interesting application in case that we have to teach the nurse, for example, for learning. So the nurse can learn how to set up the surgical operation table together with the robot. We are doing this work in collaboration with a real surgeon that is helping us in setting up our robot in this case. So this is an example of the virtual operating table, and an example on the right you can see the virtual operating table, and on the left you can see the knowledge base of the robot that have to assist the nurse to set up the table. Okay, another application of this, another outcome of this research is the role of emotion in inner speech. Typically, we humans typically use inner speech even in case when there are emotions involved. So, for example, if a person is too much angry, for example, then it starts to talk to himself, to herself, in order to regulate its own emotional state. So, and even in case if I feel that I'm too happy, because I'm far too happy, then I start to myself in order to calm down and so on. Or if I'm angry, if I'm annoyed, and so on. So inner speech and emotion are tightly related because of the self-regulation use, but even in the case that I want to better understand what is my emotional state in order to better appreciate my own emotional state. Because in many cases, I talk to myself in case I want to better understand what is I'm happy or I am angry and whatever. Therefore, we added an emotional model, a model of emotion in our architecture in order to add the inner speech aspects so that the robot might generate some form of inner speech which is related to the robot emotion. Therefore, the inner speech is generated to the robot, is related to the robot emotion. And so there is a sort of empathy between the robot emotion and the user emotion, and therefore, so the robot emotion is related to the user emotion, and then the robot is able to generate some inner speech by taking into account the emotional state of the user. We recently presented this architecture at the main conference of the International Society of Research on Emotion in July in Southern California. Okay, another outcome of this research is the role of inner speech in ethical behaviors. In this sense, I showed you a very simple ethical case where the user asks the robot to put a fork in a different way than the etiquette, but there could be situations where the user needs to have a better ethical awareness of the situation. And in many cases, we imagine a simulated scenario when in a nursing home, for example, there is a patient that may suffer from dementia, and then the robot set up the spot for the patient, and the interaction between the user may allow the robot, with inner speech or without inner speech, may allow the user to better understand the situation. So, for example, the robot might want to set up a simplified setup for a person that suffers from dementia with respect to the other people. Therefore, in this case, the inner speech may allow the user to better be aware, to be better aware of the situation, and in the sense to nudge the user to be more to operate in a more ethical way. This research, this collaboration, we are setting up this collaboration with John Sallins, which is an ethical philosopher from Sonoma State University in California. I will show you also in this case first an initial movie that shows you this application. Okay, so this is some initial experiments, some preliminary experiments, but the user, when he's setting up the table for the patient suffering from dementia, he hear the inner and the outer speech of the robot, and our impression, so our hypothesis is that the role of the inner speech may allow to the user to better understand the situation that the normal outer speech of the robot. So in this one case, that the robot says to the user, no, you cannot do this because the patient could be hurted by the knife, for example, or in the case that the user hear this similar message by inner speech, by the robot inner speech. Okay, I will continue. I will only briefly mention another collaboration where inner speech is applied. It's a collaboration between the University of Palermo and people from George Mason University and the University of Central Florida and the Air Force Research Laboratory, where in this project we are using inner speech not in a robot but in a system, where it is an experiment where the user and the softbot and an agent have to compromise in order to judge whether a situation could be whether a situation could be dangerous or could be safe. So the user is showed some situations, some scenes where, for example, there are some good people or bad people or whatever, according to the sensibility of the person, and the user and the robot look at the scenes, and they have to compromise, so they have to agree on the dangerous case, if a scene may be dangerous, or if a scene is threatening, is dangerous, or a scene is a normal scene where there are no risks. Also in this case, we are evaluating the difference between a system with inner speech and a system without inner speech. Okay, in order to concluding my talk by taking into account the problem of robot self-recognition. As I mentioned at the beginning of my talk, the role of self-recognition and inner speech are tightly linked, because self-recognition and self-observation, self-observing, even in front of a mirror, is a typical situation, is a typical trigger for inner speech. So typically, many of us, when we look ourselves in front of a mirror in the morning, or in the afternoon, or whatever, starts some form of inner speech. So it is considered the fact that there is a link between self-recognition in front of a mirror and inner speech. And therefore, we tested this hypothesis by considering our architecture when the robot is put in front of a mirror. Then we used the same architecture with robot inner speech in order to allow the robot to recognize itself in front of the mirror.
I see a robot, a mirror, and there's
So now the robot is looking if there are other robots similar to our robot near him. So this is an experiment where the robot, using the very same architecture, is able to recognize itself, started a reasoning system in order to recognize itself. I'm concluding by saying that our research, we received a very large media coverage with our research, so you might find several papers in popular media, and even there have been interviews from The Guardian, from the New Scientist, Science Daily, and even the Communication of ACM interview with us. And so there has been a very large media coverage. Okay, so I'm stop here, and thank you for your kind attention.